Step outside on a clear night, far from the city lights, and look up. If you know exactly where to look, you can spot a faint, fuzzy smudge of light. That's the Andromeda Galaxy, our closest large neighbor. While the rest of the universe expands, Andromeda is currently closing the gap, hurtling toward the Milky Way at roughly 250,000 miles per hour. In about 4.5 billion years, the outer halos of these two galaxies will overlap. Over the following 2 billion years, they will pass through each other, scramble their star systems, and violently merge into a single giant elliptical galaxy. Astronomers today call this future supergalaxy Milkomeda. This collision occurs because the gravitational pull between dense clusters of matter can overwhelm the expansion of the universe when the objects are close enough together. But our gravitationally bound neighborhood is a rare exception. To find the true fate of the cosmos, we have to zoom out past the Milky Way and Andromeda, into the empty gulfs that separate islands of stars. These are the intergalactic voids. They are regions of space so incredibly desolate that their density drops to less than one single atom per cubic meter. You could travel for millions of light years in any direction and hit absolutely nothing. Out here, the rules change. Dense nodes of matter pull together under their own gravity, but in the voids, there is virtually no mass. With no gravity to hold things together, cosmic expansion operates completely unopposed. The fate of the entire cosmos rests inside these voids, the nearly empty 80% of reality that governs the global expansion. On the largest possible scale, the universe resembles a massive three-dimensional web. Galaxies cluster into dense nodes, connected by long, thin filaments, all wrapped around those enormous empty voids. Back in the 1920s, astronomer Edwin Hubble analyzed the light coming from distant galaxies far beyond our local gravitational pull. He realized that almost all of them were receding away from us. These galaxies remain stationary relative to the space immediately surrounding them. The fabric of space itself stretches, carrying galaxies apart like raisins in a rising loaf of bread. Intergalactic distance represents a constantly growing gulf, dictated by the literal expansion of the vacuum. For decades, physicists assumed that the collective gravity of all the matter in the universe would act like a brake on this expansion, eventually slowing the stretching down. Then, in 1998, measurements of light from distant supernovas revealed a startling reality. The expansion is actively speeding up. Dark energy serves as the engine of this acceleration. Making up roughly 68% of the total energy in the universe, this mysterious force dominates the empty voids of the cosmic web. Dark energy creates more space inside those voids. They are swelling, pushing the dense filaments of the cosmic web apart at an ever-increasing rate. While gravity pulls Andromeda and the Milky Way together, dark energy is winning the global war. It guarantees that the large-scale architecture of the universe will eventually fracture. Because space stretches faster every year, the total amount of distance between us and the farthest galaxies is growing at an incredible rate. For the most distant objects, that recession velocity exceeds the speed of light. This creates a physical boundary called the cosmic horizon, the distance where space expands faster than light can return. Distant galaxies are pushed over that edge right now, their light permanently lost because the growing gulf becomes uncrossable. This expansion functions as a permanent one-way door, irreversibly erasing parts of the universe from our observable reality. Billions of years from now, the merged Milkomeda galaxy will have settled into its new home. By this point, dark energy will have pushed every other galaxy, cluster, and filament beyond the observable horizon. Future inhabitants will see a sky that is perfectly pitch black beyond their own local stars. They will possess no incoming light or surviving radiation to prove that other galaxies or a cosmic web ever existed. A moment of wonder. We exist in a cosmically privileged window of time, an era where the universe is old enough to have built massive, complex structures, but young enough that we can still see them before the void pushes them away forever.